Hello everybody, welcome back to another CS Lightwork video. It has been a long time, so I hope all of you guys have been doing well in your studies and everything that you're doing. Hope you guys are holding up well. And what I'm going to be bringing you guys today is the first of many LeetCode solution and explanation videos, and I figured what better first problem to tackle than two-sum. Two-sum is one of the most popular beginner problems you run into on LeetCode. It's what I started with. It's what everyone I know started with. So I figured if we're going to make this series, we should start with two-sum. And mainly this is because this is the first problem a lot of people tackle. They tend to go to the quickest solution and try to get it solved because, hey, it's their first problem. They don't need to worry about the efficiency that much. They just want to dip their toes in. But because of this, a lot of times the most efficient solution is kind of skipped over. So I wanted to make this video kind of explaining the best way to go about this problem and explaining the solution with and without the code. So let's get straight into it. What is this problem asking? So let's read through the given description. Given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So how do we go about this problem? What does the input-output look like? If we have an array, say 2, 7, 11, 15, we need to return the indexes of the numbers that add up to target. So here, 2 and 7 add up to 9, so you would return 0 and 1, just like so. So I'm just going to write this example out in the whiteboard so we can kind of draw through and see how we're going to solve the problem. So let's just get rid of this. Perfect. So we have something along the lines of this, and I'll just clean that up for you guys a little bit. Perfect. So this is our input and our output. So how would we go about solving this problem? Well, the first thing you might think to do is have that sort of double for loop going. Hey, let's look at 2 and then everything following. Does it add to 9? If so, return it. But the problem with this is we're looking at well over O of n speed, which means you would have to iterate through. You would be iterating through more than just iterating the list once, because you'd have to iterate through the list, and within that you'd have to go 2, 7, 11, 15, 7, 2, 7, 11, 15, and you could see how that can get sort of elongated in time and everything like that. So what's the most efficient solution to do? Now, for me, when I first heard this back when I started, it was a little almost outside of the box solution, but at the same time, it's actually fairly straightforward and simple. So the best way to do this is to actually look at the differences. So when you're iterating through, you want to look at the difference between the number you're at and the target. What does that look like? Well, say we're iterating through, we're going to look at 2 and 2. Okay, our difference is going to be 7. So what do we do with that? Now we need to keep note of, hey, we need a 7. If we run into 7, well, we already know 2 is that difference maker for target. We just need to return the index of 2 and 7. If we go to, say, 11, say 2 and 7 weren't here, we go to 11, we look at target, we say, hey, we need a -2 because 9 minus 11 is -2. So now we keep track of that -2, and hey, if we see a -2, we know that we have our solution, right? So that's kind of why we're looking through the differences, because that way we know exactly what we're looking for. So now, how are we going to keep track of these differences? There are many ways to do this, but the best approach to do this is going to be to use a key value pair. So what does this mean? Well, we're going to have some sort of data structure. We'll get into the specifics in a little bit. We'll have some sort of data structure where there's keys and values. So what does that look like? Well, all we'll be doing is really storing the indexes and the values, kind of like we do in nums. But why do we need to do that? Well, keep in mind, we're looking at the differences. So what we want to do as we iterate through, let's say we hit 2, what I want to do is, in my sort of key value pairs, I'm going to say, hey, I have the value at 2 at index 0. And why would we need that? Because remember, while we're going through, say when we hit 7, we calculate our difference and we say, hey, we need a 2. We need a 2, right? And then all we'll have to do is check, hey, is there a 2 key? Is there a key 2 in that key value pair data structure? And if there is, guess what? Just return that index and return the index we're at, and we are done. It's as simple as that. Once we get into the coding example, it might get a little clearer, but that's all we're doing. We're keeping track of the values and indexes. And every time we check a new number, we say, hey, let's look at the difference. So 9 minus 7, 2. Do we have this 2 value as a key? If so, just return the index and the index of what we're at. Boom, all done. All right, so let's look at this at a coding level. So what are we going to do? Well, first, we need to declare that data structure we're going to use to have that sort of key value pair going, as we mentioned in the whiteboard. So what we can use here, I'm using Python, but you could do this in any language. The concept and the solution applies the same way, just different syntax. In Python, we're going to use something called a dictionary, so that's just storing key value pairs, and we'll call this pairs, and we just need to declare that as blank, because right now we're not putting anything in it. And now we just need to go through our list and return if we need be. So what does that look like? The first instinct you might have here is to sort of go through a for loop and just go through each element. But because we have value for the index and we need to look at different indices and look at the values at those indices really specifically, we're going to use a function called enumerate. And all that does is, instead of going through index 0, 1, 2, 3, it also has a variable for the value. So what this looks like is something like this: for I comma n. And what this means is I is going to be the index while we're looping through. So I value is going to be 0, 1, 2, 3, and n is going to hold the value at it. So instead of saying list at I, we can just use n. Perfect. And then all we have to do is for I and n is in enumerate, which is the function that's doing this, nums. Perfect. So now, while we're iterating through, remember, we want to actually look at the differences, right? So let's just calculate the current difference. So we'll say current diff, and that's all that's going to be is going to be the target, right, minus the value what we're at. So say we're at 7, right? It's going to be minus the value at 7, which again, because we use an enumerate, it's just n. Perfect. And then now, how are we constructing this sort of key value pairs? Now that we have a difference at this 7 first index, how are we constructing this? Well, all we actually have to do is simply say, hey, in our pairs, make the key equal to the value. So the value, in this case, it's 7, and make the value at that key the difference value, right? Sorry, make the value at that key the index of it. So the reason we're doing this, it's going to be I, is because now we have something that's saying, hey, the key is 7 and the value at that is 1. So that's what it looks like sort of on the inside, where now our keys are the value and the value is the index, right? And that's how we want to keep track of it, because then when we're checking the difference, we could say, hey, do we have a key in pairs that equals the difference? And if so, boom, now we have the index right there. So what does that check look like, right? How do we actually make the check to make the return? Well, it's simple as an if statement, as you could imagine. Right now, let's use 7 as our example so you could visualize them a little more. Our current difference is equal to target, so 9, minus the value at the index we're at, so 7. So this current diff is equal to 2. We need to check if we have a 2, because that's a value we need, right? If we have a 2, we can return the 2's index and the 7's index, which is I, and boom, now we have 9. We have our correct return. So we're going to say, hey, is this current difference already inside pairs, right? If current diffs is in pairs, simple. Now, what do? We know that one of the things we're going to have to return is I, because that's the index of 7. That's one of the numbers. So let's just write this in here. We're going to return I. So that's one of them, right? And we have to keep in mind, we are returning an array of 2. So I'll keep this as blank, and we're returning I. So what's the other thing we have to do? We have to return the index of the 2, right? But what is the index of the 2? Well, if you remember, our current diff is going to be that 2. It's going to be that number you need. And if you remember in the map, the way it's stored is value index. So what we're doing is we're saying, hey, is the current difference 2 in the map? Oh, it is right here. So where are we going to get its index? Well, the value of this key is its index, right? So we're saying, hey, is current diff in pairs? Yes. So return the value that has the key of the current difference in the map. And That sounds a little bit confusing, but I'm just going to write this out and it might clear it up a little bit. All we're going to do is we're going to take pairs and we're going to return the value at current diff, right? Because the way we've done this is the keys are the values. So if current different is the value we need, hey, just return the index of the value we need. So right here, that's what we're going to do. And then I'm just going to add in a return statement right here. It should never reach this because there is always one solution. So let's just clear up that because that was just an example. And then let's just run this code right here. And as you can see, this solution was accepted, beating 86.9% of speed. I've gotten a 97 with the solution as well. But going back to our code here, again, let's just review it. We're having that declared blank key value pairs, and then we're going through the list with its index and values, and we're looking at differences, and we're saying, hey, if the number we need at the current value is in our data structure, just return that index and the index of what we're currently at. And if not, keep adding to the data structure we're going to check, right? And essentially, that's sort of how it's done. Feel free to slow down the video, rewind it, pause where you need to get through. Ask me any questions down in the description, in the comment section below. I hope this video sort of helped visualize what we're doing here. We're using a key value pair, and we're looking at if the difference is already in the data structure we're using, and then if so, just return the two indices. Apologies if I went any too fast. Again, if you have any questions, feel free to leave it down below. Subscribe to the channel, like the video. And with that, I'm out, you guys. Have a wonderful day.